This is SNN, the Smash News Network. Least busted. Naming news. And one of our regular features is our cosmology segment. So here it is. It's complicated. And we've had a number of questions about Paul Laviolette. And let me just say a brief thing about Paul Laviolette. I've considered the possibility that the sun is a neutron star and that the radiation coming out of the sun is beta decay. All right, I've considered this. However, there are problems with the things that the sun does, as it does not appear to be homogeneous enough to make this a valid or reasonable theory, as you would expect the sun to be much more homogeneous if it was a neutron star that emits light via beta decay and that the solar wind is a result of the neutrons turning into protons and stuff like that. So, I don't think it's a completely idiotic idea. Well, anyway, perhaps we'll have to look deeper into this, but currently I don't think the sun is a neutron star. Now let's talk about Uranus, or whatever you want to call it. Check out this spectacular Voyager 2 imagery at apod.nasa.gov. Perhaps add it to your desktop collection. And it gets even better, but before I talk about that, let's talk about Triton. Before I talk about that, let's talk about Uranus. Did you know that the Uranus is like the father of the entire pantheon? Were you aware of this? I mean, it's pretty berserk. So in Greek mythology, right, Uranus and Gaia are the parents of the Titans, so that they're like, did you know that? Also, did you know about Uranus's strange axial tilt, where its pole points directly at the sun? Did you know that Uranus actually emits more light than it receives from the sun? How weird is that? And the creation story associated with Uranus is horrifying. I'm not even going to read it on the video, as I don't want to get demonetized for it. But here's the rest of the apod.nasa.gov astronomy picture of the day. And it's not just Uranus. Get your head out of Uranus, as Titan is also featured in the imagery. So just fantastic. From Voyager 2 here back in 1989, they must have been popping champagne when that spacecraft took that image. That is absolutely spectacular. And I believe Triton is a very strange place, believed to have seas of liquid ethane, if I remember correctly. In other words, it may have oceans of hydrocarbons. It just seems awesome. And if you're worried about lighting a match, I believe there's insufficient oxygen to ignite the hydrocarbons. So enjoy that insanity. Today's featured object is not going to be random at all. We regularly pick random objects. Today, we're going to talk about the Vela Pulsar, as the Vela Pulsar is one of the most interesting objects in the entire galaxy. Yes, the Vela Pulsar, folks. If you haven't heard of it, check this out. It's berserk. So the Vela Pulsar is a fascinating wind nebula pulsar type X-ray source. And here are the X-ray emissions from it on the Neil Gehrels Swift-Bat X-ray Observatory, right? This is the Vela Pulsar's emissions in X-ray. And this may seem boring, just like a bunch of graphs, but we'll get into some much less boring stuff. And of course, this has got a very fast real motion as it's moving. It's not just hanging out. It's actually moving across the galaxy. But of course, the sun's moving across the galaxy. And now we've talked about naming conventions before on the channel, and I just wanted to briefly touch on this. Look at how many different names this thing has. And the reason that it has different names is because different projects have to name the objects based on their own naming convention for their own cataloging system. So this is part of the reason why things get named the way they do. Look at all the names for the Vela Pulsar. HU Vel, exclamation mark, V star, ESO 259-star012, LQAC 128. You get the idea. And you can find this on links here. If you click on SimBad, you can find all kinds of information about your favorite objects. Here's a great article from 2001 talking about the similarities of Vela and the Crab pulsar. So they're quite similar pulsars here, and they have these very similar structures. There's also a relationship between the apparent jets coming out of the poles and the torus, which is at a 90-degree angle to that, right directly around the pulsar. And in a couple additional shells are what those other shells, those are like some sort of magnetic shell layers or something that surround the torus, which surrounds the pulsar, which is only believed to be about 12 miles in diameter. An ultra-massive, fast-moving pulsar. And from this perspective, the pulsar would only be a tiny 12-mile point inside there. I'm not sure the exact scale of that imagery, but it's a quite large area, and it's a quite energetic object. So there's Vela. I think that one might actually be Crab. But anyway, here's another article about Vela. We'll just I'll let this one scroll. If you'd like to pause the video, feel free. After this, I'll make sure the stream is good. Again, we did stream this video live to twitch.tv/smAshomash. Perhaps consider installing their mobile app. It'll even alert you when we go live. It's quite good. It tells me when people are playing video games sometimes, and it's sometimes, actually, it's not very helpful. But anyway, here's an animation of what's going on in the pulsar. And I would just note one thing here. It's kind of important to cosmology, and I believe the way all stars behave. The relationship between the torus and the poloidal jets. Now, I'm not sure what the time frame of this is. It's probably over like 90 days or something. And this is the X-ray imagery. And you can see how violent this area of space must be right here. The area very close to the jet of the Vela pulsar. But what's more interesting about it is that it has this spiral-like feature. See the way it has a spiral-like feature to it? It looks like it's a spiral. And is that because it's a Birkeland current that's powering the pulsar? Well, probably not. What it most likely is the precessional wobble of the pole of this pulsar. So all rotating objects have a precessional wobble. If you spin a top, right, here's a crude drawing of a top. If you spin this thing, it's going to have a precessional wobble where its axis wobbles back and forth and back and forth and back and forth. All stars, planets, galaxies have a precessional wobble. And what you're seeing here is that the jet, when it is aligned to the magnetic field associated with the rest of this system here, is at a higher rate of output. And when it's not aligned with the magnetic field, it's at a lower rate of output. And that's simply the way stars and galaxies and pulsars seem to behave. So what can we glean about the way the sun behaves from this? The sun has a precessional wobble too. And without giving away too much about the inner workings of the sun in this day's cosmology segment, I'll just leave it there. Hopefully that taught you something about the way the torus is related to the poloidal fields. And that's today's cosmology segment. Thanks for tuning in. By the way, I've been your host, Dan, aka smAshomash, signing off from Smash News Network. Least busted. Name it news.